Now we're gonna find the matrix of the rotation by beta counterclockwise of some point M that has coordinates x and y into some point M prime that has coordinates x prime, y prime. Okay, here we assume that we have a coordinate system that's a rectangular coordinate system, x, o, y. Here we have some E1 and E2 that are unit vectors. That means the norm of E1 is equal to the norm of E2 is equal to 1, and we have a 90-degree angle here. Okay, we assume that M makes an alpha with the x-axis, and here we have the beta that M rotated by to get into M prime. So we proved in one of the videos that the norm of M is equal to the norm of M prime. Okay, now we're gonna find the matrix. Okay, we assume that we are turning or rotating counterclockwise in this direction. Okay, so we can express x and y in this coordinate system here. So here we see that M has, let's call the norm of M. We're gonna use this notation here for the norm. Let's call it, most of the time we'll call it R. Let's call this one R, and let's call the norm of M prime R prime. We know that it's R. Here we're gonna find the x and y coordinates in terms of alpha. So therefore, okay, if we project here, we know that x is gonna be R cosine of alpha, and y is gonna be R sine of alpha. So to see that, it's just take the cosine, which is this one here, and the sine, which is this one here. For M prime, we have this is for M. For M prime, we have this angle is alpha plus beta. Okay, therefore x prime is gonna be R prime cosine of alpha plus beta, and y prime is gonna be R prime sine of alpha plus beta. Okay, now if we try and expand these results, here we know that x prime is gonna be R prime cosine alpha cosine beta minus let's keep the R prime outside, minus sine of alpha sine of beta, and y prime is gonna be R prime sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay, now we can see that we can rewrite it one more time as here we proved that R prime is just R. Okay, so here we're gonna do R cosine alpha, okay, times cosine beta minus R sine alpha sine beta, and y prime is gonna be R sine alpha cosine beta plus R cosine alpha sine beta. Okay, here we see that we proved in a separate video that this R prime is equal to R. Now we're gonna switch back here, 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 here. This is R cosine alpha, this is just X, and R sine alpha is just Y. Let's do that. We're gonna have X prime is X cosine beta minus Y sine beta, and Y prime is gonna be Y cosine beta plus X sine beta. Okay, and if we can write this one, okay, we see that we can write this one in the following manner. Okay, if we so if we can move this one here to make it easier for us, so we're gonna move this one here a bit. Okay, so to show you why we need this one, y prime, if we just move the x here, it's gonna be x sine of beta plus y cosine of beta. I didn't change anything, I just moved this one here to make it clear when we are writing the matrix. Okay, here we have x prime, y prime. X prime is gonna be x cosine beta minus y sine beta, and x sine beta plus y cosine beta. Okay, if we try to write this one in a matrix form, we see that we have cosine beta minus sine beta cosine beta times xy, and this is our matrix. Okay, let me rewrite it clearly here. X prime, y prime is cosine of beta sine of beta minus sine of beta cosine of beta times xy. Okay, so here we have this form because we are rotating here in this direction. If we have done it in the other way, so this is our beta is going this way, or alpha is going this way. If we had changed this one will change. But we can use any change from this one here to find any matrix that we need. Okay, for now this is the matrix. Remember, we are rotating m by beta counterclockwise. This is what we need here. This is the form, or this is the matrix that tells us everything about our rotation. Okay, thank you very much. If you see any errors or mistakes, please let me know. Thank you again.